Hello, everyone. Welcome to this webinar on project management with MATLAB, Simulink, and Git. This is Afnan Ahmed. I'm an application engineer at CES, and CES is an exclusive partner of MathWorks in the Middle East region. A few logistics before we begin. If you have any problem hearing the audio or seeing my screen, please contact the webinar host through the chat panel. And if you have any questions, please type them in the chat panel. My colleagues from the application engineering team will be available for you in the chat panel. So let's get started with this webinar. Suppose if you are working on a project with MATLAB, Simulink, or both, chances are you're working with multiple files that are spread over several folders. And suppose if you have created and implemented something using MATLAB script, and you have also created a beautiful functioning Simulink model, but now you make some changes, maybe to try a different approach or to try a different logic. And the next day you recognize that, oh, that was wrong and I messed up with my model. So what do we do in this case? We usually want to go back to a previous state that we hopefully saved. But the question is, did we save the model first or did we save our files? And if we save the previous state, how did we save that? So this is what we will be discussing in this webinar. And people either make the copies of several folders like version 1, version 2, or they keep on emailing themselves with the updated code or updated model, or they don't even keep the track of changes what they are working on. And many of you might have been end up with this kind of folder with multiple folders that is filled with a lot of programming files or your models. Now the question is there a better way how I can manage my project in one single integrated environment for all my Simulink and MATLAB files and my uh, resources? Yes, there is a better way, and that we call it as versioning system. So versioning system does exactly the same for you. And I hope many of you might be aware of versioning system, and you guys might be using the versioning system like Git or SVN. It is extremely helpful to collaborate with the team, and it is always recommended to make use of the versioning system when we are working with a team size of 2 or more. And now what is the support from the MathWorks and the integration of versioning system? So this is what we will be discussing in this webinar, and this is the agenda for today's session. We will go through a short introduction to MATLAB and Simulink projects, how to manage the project path, how to automate this startup and shutdown script, create the shortcuts from the project tab for all the commonly used files so that we will not be like lost in many folders or the files searching for a specific file, and a short introduction to the source control and how to integrate MATLAB and Simulink projects with the source control that will help us to keep a track of all the changes that we do and commit all the changes from the local repository to the source repository, and how we can create a branch to avoid any changes or the direct changes to the main branch or the main files. And once we are done with our experiment, how we can merge these sub branches to our main branch. And finally, we will see how to push and pull all the changes we do from our source repository to our MATLAB and Simulink projects. First, let's discuss the capabilities of MATLAB and Simulink projects. Projects allow us to manage complexity by helping us to organize, manage, and share your MATLAB and Simulink code in one single environment, and also an interface that works with all for both MATLAB and Simulink. So let's go around this diagram. In simple words, project is nothing but multiple tasks that are bundled together. And in terms of model, is going to be the artifacts that are bundled together. To start, you can create a new project in several ways. You can create a new project from the MATLAB toolstrip. So this is a MATLAB toolstrip. You can create a new project from here, a new blank project, or a project from the existing folder, or you can create a project uh, from Git or Subversion repositories. But in case if you have an existing folder locally on your machine, you can wrap it in a project with just few clicks, and all the files will be automatically added for you in your project. Now you might be thinking like, why would I want to do this? Why I want to convert all my files into a project? So let's see a few reasons why we need to, why it is recommended to work with MATLAB and Simulink projects. Generally, when we work with our projects, we don't have to worry about setting up the path and the environment before we open or run our models or the MATLAB scripts. We will just open the project and all the MATLAB path and all our files will be automatically set up. And also startup and shutdown scripts that you specify. These scripts will run automatically and all our data and utilities will be added or will be loaded automatically when we open our project. For automation, we don't have to write a complex MATLAB code to add and remove files or folders from the MATLAB path. We can just simply add it once from in the project setting, and we don't have to worry it again because all the things will be available for us when we open our project. And when we close our project, the path will be cleaned when we close our project. So at the same time, the tool will also check for the shadow models and configure all the projects to set up the model templates and theme preferences like utilities or the reference model. And you can also create the shortcuts from the project tab. So maybe it's gonna be from the top level, but it is very helpful to make the things available easily for everyone when working on one single project. So in case if we have worked on a wrong file or a folder, because we may have two or more models with the same name and we didn't realize that and we picked the wrong one. So in that case, we definitely want to avoid this because MATLAB projects, it will run few checks before we get started, and working on a wrong file is going to be very costly, and we definitely want to avoid this error. Another critical issue is losing our work because of unsaved changes. Suppose if we are working with multiple MATLAB files and multiple Simulink models, and we suddenly close our MATLAB, and we recognize that next day we recognize that, oh, I didn't save a few of my files or a few of my Simulink models, and it's gonna make a huge difference. And those changes, it matters a lot. So projects will help you to see all the unsaved changes, and that way you can easily save or discard all the changes for individual file and also for the entire project. One of the most helpful capabilities of MATLAB is the ability to visualize the changes and understand the dependency between the multiple files in our MATLAB project. So it is, if you are working with hundreds of files, when we are working on a complex project, we'll have hundreds of files. So when you have a large project, we can perform the dependency analyzer. And this dependency analyzer will give you a relationship between the files, how they are connected, and also the dependencies on the file. At the same time, it will give you the list of products that are required for this particular project, and it will also report all the errors or the missing files in my project. So when we make some changes to a file, like renaming the file and or making any changes inside the file, the tool will show you other changes and how it is impacted on the rest of the files. And it will also help you to automate uh, the renaming process with just one click, and you can update all your files automatically and you can move on. This is very helpful when we are working with library links, especially with model references, model callbacks. And another advantage of having all the files in a project is you can run batch operations on them. That means if I make any changes or check on multiple tasks, we don't have to do it one by one. So when we are working on a complex project, we have hundreds of files. So definitely we don't want to get inside each file or each model to make the changes. So we can run some custom task on multiple files at the same time. For example, we can run a MATLAB code checker on all M and MLX files. And Simulink projects also help us uh, to with the renaming buses and renaming element process. So when you have renamed, let's say when we rename something, we might jump into 10 different models or 10 different files, updating them manually. But with the help of Simulink projects, we can avoid doing this and we can automate the process of renaming or any updates we make. And when we make any changes we have been discussing about, we need to maintain a historical snapshots or and we need to maintain a historical snapshots of all our artifacts or the changes what we make so that we can easily return to our previous state. So that is what source control is going to do. And MATLAB, with MATLAB projects, you can integrate with source control to track your changes that are being done to your MATLAB code, or to track the changes that are being done to your Simulink model, as well as who is responsible for those changes. So that makes it very easier for multiple peoples to work in one single code base. So okay, so you can track all the changes that are being made to your model, as well as who is responsible for those changes. So you know who the like if you need any clarification regarding the changes, now you know whom to approach to clarify your queries with different versions. And also source control can automatically merge. So here you can see in this diagram that we have a main branch and we have created multiple branches. So uh, like if we have multiple developers working at the same time, we can make use of we can create the branches, make the modification, and merge the branches to our main branch. And here you see an example of the project and the git status here in the file view. We can compare the difference between the versions and resolve the conflicts. We can also automate the process of merging the files whenever it is possible. And at the same time, we can perform the tasks like push, pull, or fetch all the changes, and also commit all the changes directly from our tool script. So this is our tool script. We can perform all the changes just by one click. So by this, with the help of this, it will simplify our comparison and merging workflows. You can make use of model comparison tools to compare and track the changes between two different versions. Suppose if I have a base version and then now I make some changes, and then now I want to compare the two different versions, what changes I have made or what updates I have done. So here you see in the tool step, there are two different versions, and one in the right here, sorry, one in the left here, you will find a text-based representation. And on the right, it's going to be the graphical representation. So this is the case when we are working on a Simulink model. We can see uh, we can compare two different versions, either gonna with the text representation and also with the graphical representation. So this is a great feature to view the difference in the model elements or the state flow charts and also the MATLAB function blocks. Okay, we can also make use of three-way merging that is available for us with the help of Simulink projects to show the changes in the original model and to filter and save the comparison results. So Simulink projects, with the help of Simulink projects, you can automate the merging workflows, automate and merge the branches that contains multiple subsystem or the state flow charts or the different configuration setups. With the three-way merge flow, you can visualize the changes that you have made. So suppose this is the changes what I have made, and I have a base file from where I started, and I can also compare with my colleagues or the teammates. Suppose if we are working on a team, I can compare and on if the team is working on one single project and one single file, I can also compare the changes what I have done and what my colleagues have done with the base file or with these two different versions, so that we can merge very easily and which has the expected output, and we can continue with our project. In addition to source control integration, projects give a way to componentize your development with MATLAB with project references. That means you can have multiple projects that works together with other projects, and the goal is to and the goal is to componentize the development process. So you can explore the full project hierarchy here and all the files that are associated directly from the project. And you can also view the references in the hierarchy. So you can view all the files and the modification for a specific reference. Finally, project help us with the upgrade process. So it is very easy. It's a very easy workflow to update all my models or all my projects with the latest release. Suppose if I'm working with an like say 2022 B version, and I want to update with the latest version, let's say 2023 B. In that case, project can help you to automate update uh, process. So we don't have to jump into one single model one by one and keep on updating. But with the help of this update feature, we can update all the process, all the project, and it will also automatically run the compatibility checks for MATLAB and Simulink files. And if applicable, it will fix the issues automatically, and it will generate the report for us. So in the end, it will compare, it will update, and it will generate the report for us. This is general outline of integrating with integration of MATLAB and Simulink projects with the source repository. We have a remote repository from the, maybe it's gonna be from the source control, and we have two different users, and we have a local repository on their machine. Suppose if we want to try a new experiment, we can create the branches, make the changes. If the results are satisfactory, we can merge the branches, check into the local repository, and we can directly push or pull the changes from the local repository to the source repository. So one of the powerful capability of source control integration is creating and merging multiple branches from our project. For example, when we are working with in a team and we have two different concurrent developers and they are working with multiple files. This feature is used for working with new approaches, or if you want to perform some experiments without affecting the main branch or the master branch, so that we will not make the changes to our base file directly. So we can create the branches. By default, we will have in MATLAB projects, we will have a by default branch called master. We can create a branch in the in our repository, we can not just one, we can create multiple branches, make the changes that we are interested to do, or make the perform the experiments. If the results are satisfactory, merge it with the master branch, and at the same time you can you can pull all the changes from the master branch to your sub branch what you are working on. And after performing all your experiment or the changes, you can merge it with the master branch. So this way you will not make any changes directly through your reference code or the reference model. So now let's go to our MATLAB and see how we can perform all these things what we have discussed now. Okay, so this is a MATLAB environment. Now to create, uh, so I have a model here. So this is a Simulink model, which is we have developed for vehicle dynamics. It's a 14 degree of freedom model. When I have just opened this model from my folder. Now when I run this model, it has, let me wait to execute this model. So I have all these files in my uh, current working folder. So as you can see here, let me wait to execute this. Okay, so this is our Simulink model. What we have, it is a 14 degree of freedom for performing vehicle dynamics. And if I go inside this model, there is some serious sim mechanics inside this model. So representing uh, this the vehicle dynamics. So for now, let's do, this is not what we will be discussing in this webinar. Let me go to the actual one. Okay, so as you can see here, this is performing. We are performing some checks on our vehicle. So I have multiple files, and now if I want to wrap up all these things in one single project, I can do it very easily. So to start, we can create a new project. We can create a blank project, or if I have an existing folder, we can create a project from the folder. We can also create a project from the Git and Subversion repository. So for now, let me just create a blank project. So when we create a new blank project or new project, it will ask for the folder or the path. Let me just select the folder, and let me give the name as vehicle dynamics. Click on create. Okay, the specific contains. Okay, let me. So when we create our blank project, so as you can see, there are no files in this one. Now we need to add all our files to our Simulink for this project. So when I open this project, this is an empty project. So we need to add all our files to this project, and we will see and we'll perform all the uh, steps what we discuss in our presentation. So now to add our projects, go to, let me go here. select folder. Let me add all the files to my project or the folder. Okay, so I have added all my folders and inside the project that I have recently created. So I have all the files here, my reference models, overview of what I'm doing, and the resources. So now you can see the status here. Like if I just take my cursor to the status, it will show you. It will show me what it is. So this is inside the project now. And in case if I want to add all these folders to my uh, project, just select all the folders, right click and click on add to project. So when I click on add to project, all these files will be automatically added to my project. Okay, so now we definitely want to integrate this with the source control so that we can make some changes and compare our changes. And the best way to like in case if I don't know how to integrate with the source control, the best way is I can start with the documentation. I can just go to the MATLAB documentation to set up with the Git source control, and you will find all the details here. Okay, so to integrate this project with the source control, let me go to my source control first. Okay, so this is my a Git environment. Suppose in case if you're not familiar with Git or the source control integration, you can just go to the this website that is Git, and you can just explore the documentation or click on about, and you will find the documentation for the Git here. So now let me go back to my uh, my let me create a new repository. So I have all the repository here. Now I want to create a new repository. So let me create a new repository, and I will give a name as dynamic this. Okay, so you can select it's gonna be public or private. So let me just select it as private, and I will click on create repository. So now it will create a new repository, and in our this is a Git environment. It will create a new repository, and I need this path or this link. So let me copy this, and let's go to our MATLAB. So to integrate this project with my source control, just click on right click here, click on source control, and click on manage files. Now, when you click on manage files, it will ask for the repository path that we have just copied from here. So let me copy this, and I will paste it here. Okay, so I will say retrieve. Stop. Send empty folder. Okay, I need to select the folder first. Let me select the folder first. Okay, so I have my folder, and I will click on retrieve. So Now it will run all the process, and I will have this folder integrated with my source control or the source repository that I have just created. Okay, so now we need to add all our projects or all our files to our source repository so that we can make some changes and we can compare the changes. Let me go here, Dynamics 1. Okay, so home project, project. So I have created a new project, but as you can see here, when I create a new project, it will ask for to set up the startup files or to set up the project. So when I click on set up project, it will ask for all the folders and the files what we are interested to add to our project, and also the startup and shutdown files we can specify here, so that when we open our project, all these files will be executed, or it will run and set up the environment to work on our project. So for now, let me just ignore that, and I will in the next step I will show you how to add all the files or define as the startup and shutdown script. Okay, let me add all the files to my this is a project view. Uh, Click on all and you will find all the folders and files that we are working on the current folder. And when you click on project, it will give me, you can see all the folders or the files that are added to my project. So let me go back and add all the files to my project. So, okay. Now, as you can see here, I have all these files and it has been added to my project. In case if it is not added, select the files or any script, click on. So right now it is already added to the path. If I click on remove from the path, all these files will be removed from the path, or at the same time, I can, let me show you the next one. I can also add all these files or the folders to my current project. Okay, so now let me open one of the model from here, any one of the model. Okay, so this is the model what we saw initially, and if I look under this, what do we have is there is some serious sim mechanics or the vehicle dynamics. Okay, so now we have this model, and now I want to add this model to the source control or to my uh, the source repository. So in the git status, you will see that like this is not under source control. So we definitely want to um, add all these files to our source control. So to add all these files to our source control, just right click here, click on source control, and click on view and commit changes. So when I click on view and commit changes, I will have all the files that have been just recently added to my project or have modified recently. And it is always recommended to add a comment before we commit any changes. So let me give the name as, or the comment as, base files. Comment the changes. Now you can see that there is an update here. And I click here. So all these files, as you can see here, these files are added to, or it is committed to the source control, and all these are unmodified. And now if I want to push all the changes to my source, I can push it from here, or I can also push from here. Just click on push. It will push all the changes what we have committed to the source control. Okay, so now let's see. Currently, this is not under source control. So let's see, add all the files. Okay, so this is under the project. Okay, so let me open one of the model and make some changes here. So when I open this model, let me go under this, and you can see how this model is being defined. So let's go inside and make some changes, or let me delete these and add it to a different. So I'm just breaking all the model so that right now this model it was completely functioning, and now I'm trying to change the functionality of the model. Let's say let me delete this and add it to a different field, and maybe we can go under this. We can just delete this, or let me just make the changes in the parameters. So right now the angle says 90, 180, and 0. Let me just change it to 90 and 90. So like by this way, like when we make these changes, we are making these changes, it will be so that I can compare all these changes what I'm doing. Okay, so let me go back and let me change it here from X, Y, Z. So currently it's X, Z, Y, and X. Let me change it to X, Y, and Z. And let me change the this make some changes inside this field. So currently it's X plus. Okay. Uh, Let me just delete this. Okay, this is a library. I cannot make any changes because, okay. So now I have made some changes. Let me save this. When I save the changes, okay, so I have made the changes and I have saved all the changes that I have done. Now when I made the changes, so let me go here, go to source control. Oh, wait, I'm working on a different wrong file. All files that we are working on. Okay, so I have made a few changes in my model. So before comparing, let me perform the dependency analyzer and see how these files are dependent on each other. So click on dependency analyzer and click on analyze. When I click on analyze, it will give me a graphical representation of how my files are dependent on each other, or how they are interconnected. At the same time, it will give me if in case any files are missing, it will give me like, okay, 7 files are missing in my current project. So let me zoom into this, and here you can see how these files are dependent on each other. Or let me try to change the name of this file. So when I just click on this file, select this file, it will give you an overview how, like, what is required for this file and the products that are required, and a short details of this file. So let me try to let's say I want to make any changes here, like say add a label. Okay, so I can either add a label, or let me make some changes here, and like maybe renaming the file, remove the label. Okay, and let me do it here. Maybe like let me remove one of the file from my project. So now when I run my so let me remove. Now when I run my dependency analyzer, just click on impact and it will show you how it has been impacted. Or click on analyze. Model hierarchy. And at the same time, just if you want to go back to your previous state, just click on restore to default. It will restore all the files to the initial point where we started. So like this is one of the way how we can visualize or graphically visualize how our files are dependent on each other. And at the same time, it will report the problems what we have in our project. So currently there are 10 files that are missing, and like file is not in the project. So few files are not added to project. So click on how to fix a problem, and here you will find the documentation to fix your problems, or the errors for the missing files that are missing in your project. So let me go back here and close this dependency analyzer. Okay, so let me run this. Add to the source control. Continue source control, manage files. So currently, like the previous project what we were working on, I deleted few of my files so that I can demonstrate how it was affecting when few files are missing. So let me go back to the actual working folders. I have a vehicle dynamics. Select a folder. Select all the files that, or just select this. Add to path. So when I'm working on this one, I need to select and like add all the files to my current path. But when I make use of the project, with the help of the project, we can all these environment, it will automatically set up when we define our models as, or the script as startup and shutdown script. So let me show you how to add, or how we can define as the startup and shutdown scripts. So I have a project here that I have created previously, and let me perform the dependency analyzer for this particular project to see whether my files are missing or not. So let me go to dependency analyzer, click on analyze. So here you can see all the files that are how the files are dependent on each other. Okay, so let me go back to my file. So this is a file view, and currently this project is not under source control because I created a different one. So let me integrate this with the source control repository. Okay, I'll copy this, and now let me add this to the source control. So when you select the source control, you can either select the source control as Git or Subversion repository. So for now, for this session, we will stick to the Git. Select the Git and select the repository path for the source repository and click on retrieve. Okay, we just need to create an empty file. New folder, select this folder. Okay, so click on retrieve. I will have created a Git, and you can see the Git status here. But currently, all these files are not inside this path. So let me go back and add all this to my uh, source control. Okay, so let me create a new project here. Dynamics test, select and create. Okay, so we have our project here, and let me add all the files to my uh, current project. Yes. Okay, so now all my folders are here, but these folders are not under the source, are not under the project. Now to add all these files under the project, select and click on add to projects. So by doing this, all these files will be added to the project. So let me select all the files and click on add to project. So after doing this, you will have a check-in here, representing this we have added all these files are inside the project. And now we can make push all the changes or commit all these changes what we have done to our source repository. So let me name it as base files, commit the changes, and after committing the changes, I can push all my changes what I have done, or currently I have added all these files to my project. So I can push all the changes to my source control And here you can see current branch is master branch and status is normal. So let me go to my model and make some changes here inside my model. What we did previously. So let me delete this and connect it to somewhere else. And let me change the, let's say, let me open this and we can just delete this and connect it to some else. Select. So I'm just currently I'm just destroying all the functionality of this model. So let me close this and save the changes. When I save the changes, it will be highlighted here. The changes what I have done. Okay, so after doing the changes, I can just again fetch all the changes that I have done, or let me just rename the file here. Let's say I will say _1, and it will, when I just make the changes, the dependency analyzer will see how this is going to be affected. So it will give me like one file is renamed and it depends on it depends on this file. So there are 28 dependencies. So if I'm manually changing this, I need to manually change 28 different models and rename them. So I can just click on rename and it will automatically update all the files that we have done. So after renaming, as you can see here, like there is an indicator that is highlighted, that is one file is modified, and I need to push all these changes uh, uh, to my source control. So to push all these changes to my source control, just select here, click on source control, click on view and commit changes, and add a comment. Click on commit. So now when we push the changes, all the files will be all the changes will be highlighted in our source repository. So let me show it here. Go to repositories and we can see that I have just recently updated. What I have done, that is renaming the files. So I have just renamed these files and added to my source repository. So let me add these files to my source control. Okay, so now when I have made all the changes and I want to compare, so to compare the changes what I have done, just click on source control and you can, okay, before comparing, let me just explain how to create and merge branches. So click on merge, click on branches. So now as you can see here, I have only one branch called master. So I can create a branch from here, create a branch. Let's say I'm gonna create a test branch. Click on create. So, and from here you can switch to the different branches. And if you want to revert to the head branch, just click on revert. So it will give you revert all uncommented files and changes. If you want to revert, just click on yes. If say, you can just say no. And now, like I have created two different one, and let me close this. And again, if I make any changes here, let me rename this file now. Remove from the shortcut. Let's say I'm gonna rename this file. Rename. And now when I go back to my branches, so in the test branch, I will have like who is the author, that is I have done some changes, and when did I change the files. So if I'm satisfied with the results, and in case if I'm working on my Simulink model here and I make some changes to try some new experiments, in that case I can save the changes back to my here. I can create a branch, make the changes, try some new experiments, and after making the changes, we can just go to branches here again, and we can just merge it with uh, the master branch. So let me close this, and here you can see the changes what I have done. Okay, so again, to commit all the changes, go to view and commit. Let's say new branch, commit all the changes. And now when I like if I want to compare the changes what I have done, click on compare, click on source control and leave details. Okay, compare against control. Okay, so let me compare from here. I haven't made any changes for this file. So currently this is inside. Let me rename. So whenever I make any changes, I need to keep historical snapshots of my changes. So I have done some changes to this file. Okay, and I have revisions of this file, but I haven't done any changes to this. So let me see how I can compare with the text-based and graphical representation. Here you can see that I have made some changes and who is responsible for the changes and a few comments that we added. So I have created a new branch and I have made some experiments here. So when I click on compare to local, it will compare. It's oh, compare to revisions. Okay, I need to make, okay, I'm working on my master branch. Revert to head, yes, close. Okay, so let me add one more, let me make one more changes here so that I can compare two different files. Just running out of changes. I will say changes to commit, and now I will be able to compare two different versions what I was working on. Oh, I need to push the changes first. Okay, so here you can see like the changes what I have done. So if I want to compare to local, what I'm working on the local repository. So currently I don't have any local repository, because of which I have a message that is displayed. So obviously if I have a source repository or the local repository, I can compare my different models. So click on compare to revisions, compare to local. Let me make few changes in the model. let me just, let's see, I want to delete these. Okay, so currently I have deleted this block and I saved the changes. And after making the changes, you can see there is an indicator that is indicated saying that this has been modified. So now I want to commit the changes, go to source control, click on view and commit changes, and I will add the comment as broken model. Commit the changes. And now if in case like I have completely broken my model and I'm not sure what I have done. So in this case, if I want to go back to my previous state, just select the model, click on source control, and now you will see compare to revisions here. So when you click on compare to revisions, you will see two different models. That is initially like we started with renaming the files, but we didn't change the functionality of the model, and we have completely broken model that I have like and both the changes is done by me. So select the models and I will click on compare select. It will select all the files that I have selected. It will perform a comparison test. And after performing the comparison test, it will give me a result. So here it is. That is, I can see the changes what I have done. And in a text representation and also in the graphical format. So this is a graphical format. And here you can see that like what changes actually I have done. That is, I have deleted this block. So this was my first version and this is my version 2. And you can compare the changes in the graphical format. Or in case if you want to see the changes in a text format, you can see in this way. And now if I want to say, I want to, let's say, let me close this comparison. And okay, I'm sure that's like I have completely broken the model. So if I want to get my previous model, click on compare to revisions, or instead you can reverse using the git. So this is one of the capability of integrating MATLAB and Simulink projects with the Git repositories. So when I click on reverse using Git, I can select the model that I want to revert, or let's say I want to revert my initial files in which I just changed the name, but I didn't break the functionality of my Simulink model. So I can just click on revert. It will revert all the changes, and after reverting the changes, you can see that I have modified the files, and now again I have to commit. So to commit any changes, either you can commit from here or just right click, go to source control and commit the changes. So let me commit it from here. So I'll rename, add a comment as reverted model, submit. And after committing the changes, I need to push all the changes back to my source repository. Click on push. It will push all the changes that I have recently done. And now when I go back to my uh, model in my source repository, so you can see that I have just recently reverted this with a comment called reverted model, and I have made the changes just 5 minutes back, and I have also added these files to my source repository. So yes, this is how we can uh, add the project, made the changes. If you are new to MATLAB and if you are a beginner, it is very easy to get started with MATLAB. and MathWorks products. There are few, like many on-ramp courses, which will help you to quickly get started. And these courses are free of cost. There are multiple courses that are available free of cost. You can take all these courses and get started with MATLAB and MATLAB products and get familiar with the environment. And in case if you have any questions or if you need any assistance in your work, just reach out to us. Just drop an email, and we have a dedicated application engineering team. We have been supporting our customer. We have been supporting our MATLAB users, uh, integrating MATLAB and Simulink in their workflow, helping them in the development of their projects. So you can reach out to us, just drop an email. We will be happy to help you out in your projects.